Hello guys, today's topic is pure substances. Learning goal. I can describe what is matter and pure substances. I will be able to classify substances as pure substances. Keywords. Pure substance. It is a single element or compound that is not mixed with any other substance. What is matter? Matter is any material that occupies space and has mass. It includes all solids, liquid, gases. Pure substances. A pure substance is made up of only one type of matter. A pure substance cannot be separated easily. Example, gold, pure water, carbon dioxide, and many other examples are there. A pure substance, it may be an element or a compound, have specific melting point and boiling point. For example, pure water consists of one type of compound, that is oxygen and two hydrogen, and has boiling point of 100 degrees Celsius. Anything made up of two or more type of compounds is not a pure substance. Okay, it's question time for you. Argon is a pure substance. It means it will have, every time on heating it, it will have a different melting point. Second is, it will have a specific melting point. Think, pause, and then check whether you're right or wrong. If you answer that it will have a specific melting point, then you are correct. A chemical pure substance will have specific melting and boiling point, whereas impure substance will have a melting point range or boiling point range. There will be no fixed melting or boiling point. Another question for you. Let's see in the last slide what have you learned. Can you tell which substance or substances are pure? The first one is substance A has melting point of minus 210 degrees Celsius and boiling point of minus 196 degrees Celsius. The second has a substance has melting point range of 23 to 26 degrees Celsius. Third, a substance has boiling point of 17 degrees Celsius. And fourth, a substance melting point lies between 35 to 40 degrees Celsius. Pause the video, think that which substances are pure and which are impure, and then check whether you're right or wrong. If you answered first and third are pure substances, you are correct, and second and fourth are impure. This is because they are having range of melting and boiling point, whereas pure substances will have a fixed boiling or melting point. Melting point analysis. We can determine melting point of a substance using melting point equipment. In this image, you can see the apparatus. It has melting point tubes. In here, this is the capillary where you add the solid which has to be melted. This is viewing window where you can see whether the melting has taken place or not. Here, control heating control, where you can control the heat, you can increase or decrease the temperature. Connects to a data logger. This is data logger. In here you can record the temperature at which the solid has started to melt. In this image you can see this is a capillary, and in this capillary you added solid. When you increase the temperature, the sample begins to melt. That is your initial melting point. And there will be a time when all of the solid will turn into liquid. That will be a final melting point. And just remember this thing, that the temperature between these melting points will remain constant. It will occur at the same temperature only. Use of determining melting point. Why we need to check melting point? Melting point is used to assess the purity of a substance, as pure substances have a specific melting point rather than a temperature range. This is because all particles are identical and they require the same amount of energy to break their bonds and transition from solid to liquid. For example, pure gold melts at 1064 degrees Celsius. If impurities are present, the melting point decreases and becomes less sharp, which is why scientists use melting point to check purity. So always remember, if you have to check whether a substance is pure or not, you check the melting point of its first. Typical heating curve. Typical heating curve for a chemically pure substance. Make sure that you have a paper and pen with you because this slide will have too much information for you. On the y-axis, you can see temperature. It is in degrees Celsius. As you move along x-axis, it denotes time, which is in seconds. And consider that you have a pure substance which is in solid state. We started to increase the temperature. When the temperature increases, the energy is transferred to the particles. The particles of solid state are in a fixed position and they start to vibrate. As the temperature increases, vibration also increases. Okay, there will be a point when the solid starts to melt. This is known as melting point. When the substance starts to melt, the energy is used to overcome forces of attraction between the particles so that they can move past each other. From this point to this point, the particle of solid state will melt. Now just see in here that the temperature is same, only the time is changing. Time is moving like this, so only there is variation in time, but the point or the temperature remains the same. Okay, now what happens is when the substance melts completely, only then the temperature will start to increase again. When the solid state has completely melted at this point, only then it will start to increase the temperature. When more energy is transferred, particles start to move more, and then it reaches this point, which is the boiling point, and at boiling point the liquid start to change to gaseous state. Make sure that you have written all the points which I have told because they will be helpful for you to understand this graph. Next is typical heating curve for an impure substance. Now, for a pure substance, you had a fixed range, like it was like this. The temperature melting or the boiling point were specific. Whereas for impure substance, there will be a range of melting point. You can see it is melting here also, at this point also, at this point also. Whereas when we were talking about just pure substance, it had the solid line. That means there was a specific temperature and the time was increasing. In impure substance, time is also increasing and the temperature is also increasing. So there is a range of melting and boiling point for an impure substance. Now come the typical cooling curve for a chemically pure substance. Cooling is when the particles move from gaseous phase to solid state by the release of energy. Now what happens is when the substance cool down, particles transfer heat to the surrounding. The movement of particles slow down. A substance in the gas state will condense at its boiling point. This is the boiling point, and change into liquid state. Then this liquid state will freeze at its melting point and will turn into solid state. Similarly, the graph is for a typical cooling curve for a chemical impure substance. For an impure substance, there will be range of boiling point. Similarly, there will be a range of melting point. For pure substances, there was a fixed point, but for impure substances, there will be a range. Check out YouTube Shorts or Instagram handle or TikTok for related practice questions.